What's up everybody? Welcome to Coding with Chaim. In this video we're going to take a look at 7 more React interview questions that you really need to master. You don't want to miss this, so stick around. Okay, before we actually jump into these 7 React interview questions, let me just remind you that you can find the first 7 React interview questions that we covered last week. You can find the link to the video down in the description box below. So with that out of the way, let's actually jump in and start taking a look at some of the questions. All right, so the first question that we're actually going to take a look at is going to be, what is a higher order component? Now, before you actually jump in and say, really, a higher order component in 2020, is that still relevant? Yes, I believe that higher order components are definitely still relevant now in 2020, and I would say that the reason why they're relevant is for 2 reasons. A, because you're still going to find them in a lot of code bases because they were just used so widely, so not everyone has basically migrated away from them. They're definitely still very widely used. 2, I think it's important to understand higher order components to kind of know where we were, to understand how we got to where we are now using hooks and render props. So let's actually take a look at an example of how a higher order component actually works. So as you can see here on screen, we basically have the simple hello code sandbox, and then it just says start editing to see some magic happen, right? And as I hover over it, you can see that it actually turns red. When I move my mouse away, it no longer turns red. Let's see how I actually did that. So what you notice is I have this basic main component here that I'm calling app. It accepts props as an argument, defines this basic style object that has the background color. And here you'll notice that the background color is going to be either red or an empty string, depending on whether or not the props that hovered that we're getting in is going to be a Boolean, whether it's going to be true or false. Now the question is, where is this props that hovered actually coming from? Well, as it turns out, it's actually coming from our higher order component over here. So you'll see down here on line 31, when I'm exporting my app component, I'm actually exporting what's getting returned from the text hover. So the text hover basically is a function that receives a component as an argument and then sort of returns a newly augmented component. And that is exactly in a nutshell what a higher order component is. So really quickly, again, a sort of basic definition of what it is it's effectively a function that receives a component as an argument and then returns a newly augmented component. Now let's actually see the implementation of how that actually happens. So you'll see here that the text hover accepts a component as an argument, then returns a new function. This function will receive props, right? And then it's going to define its own basic state of hovered, and then set hovered, and we're going to be using the useState hook to kind of initialize the hovered to false. We're then going to simply return a div. Now this div will basically have the event listeners for on mouse over, on mouse leave, which is how we can basically detect the actual hover state within React. And then all that's really going to do is then go ahead and wrap our actual components right over here. So whatever that is, whatever we're wrapping, we can just wrap out, we can just, pretty much render right over here, wrap within this div, and then we can pretty much pass down all the props that component is already expecting, in advance. And then in addition to that, we can basically pass down a new prop that we've just created here as state. We can pretty much pass down this hovered state right over here. So again, the text hover will accept the component as an argument, return a newly augmented component that now has a new bit of state called hovered, which we're going to pass down to component as a prop. And now again, the goal of why we're doing this is because presumably we'd want to have this logic of detecting hover in more than one place throughout our app. And so higher order components are basically a way that allows us to kind of share logic throughout the entire app without having to rewrite the logic over and over again. All right, so the second question in our list is going to be, what is a render prop and what is it good for? Now, once again, I'm going to say that if you're wondering why I'm talking about render props now in the year 2020, I'm going to say the same thing as I said about higher order components. I still believe that companies would still ask it. In fact, I would still ask you about render props if I was actually going to interview you, because 2 reasons. Number 1, I still have render props in my code base. A lot of companies still have them in their code base. They're still very widely used. Not everyone actually had the luxury of still, kind of moving up to hooks. Furthermore, it's always important to understand where we came from to understand where we're going. So therefore, I still think that render props is still definitely something worth talking about in the year 2020 regarding interview questions. Let's actually take a look at an example of a render prop of how it actually works. So once again, the setup here is very simple. We pretty much have the words on screen that if we hover, they turn red. If you move away, the redness kind of goes away. So once again, we kind of have this sort of same idea where we want to kind of detect hover state, and we want to share that hover state across multiple different components throughout our applications. We want to kind of encapsulate the logic in one individual component to kind of reuse it again and again. And so the way that we're doing this now is by using an actual render prop. If you look at our app component, this app component here pretty much, defines a div. This div will pretty much have a style that is going to have this, JavaScript object for styling, and it basically will define the background color just as before. and it's going to pretty much decide whether the color will be red or an empty string depending on this hovered argument that's getting passed into this function. So we have a function called rendered or render that accepts hovered as an argument. Hovered will be a boolean of either true or false, and depending if it's true it'll be red, otherwise it'll just be an empty string, right? Now who actually is calling this render function? Well, as it turns out, we're actually rendering a component called detect hover. Detect hover is a component that it will effectively accept a prop called render, and what you need to pass to that render prop is in fact a function that's going to render your JSX. That's where the name render prop basically comes from. So let's actually take a look at what detect hover does. And as you see, it's basically a simple component that's defining state of hovered and then a function to actually go ahead and set hovered. It then has a div which will pretty much have the on-mouse over and on-mouse leave events to kind of listen out for whether or not you're actually currently hovering over this div. And then within that div, we're basically going to go ahead and call the props that render. So again, render is just going to be a prop that's getting passed to detect hover. It is in fact a function, so we can just go ahead and invoke that function by saying props.render, invoking the function, and then taking this hovered state right over here, and then passing it down as an argument to the actual function. So then when we come back here, we then actually receive the hovered variable as an argument to the render function, and then we can pretty much just, decide with a ternary based on whether or not it is in fact hovered, make it red. If it's not currently hovered, then just leave it as an empty string. And so that's how we can pretty much reuse logic across our application using the render prop approach. So having now talked about higher order components and now render props, this kind of now nicely leads into what are hooks and what are they actually good for, which is basically the third question in the list. So again, what are hooks and what exactly is the problem that hooks are solving? So I would say that the sort of 2 points that hooks kind of provide is, the first one is, of course, it allows us to sort of hook into the lifecycle methods of a React lifecycle component, but without having to actually define a class, right? So typically, if you wanted to kind of be able to define state or have a did mount or a did update or anything like that, you'd have to typically be inside of a class component. But hooks allow us to kind of hook into the React lifecycle within a functional component. That's kind of step one of what a hook actually does. But also, in addition to that, hooks also allow us to sort of share logic again, just like a higher order component and just like a render prop. They actually allow us to kind of define our own custom hooks, which we can then use to share logic across multiple different components. And so I think the problem that hooks are solving, and I think that this is actually what the React documentation says, is that with higher order components and with render props, we kind of had this thing called wrapper hell. And so really, if you look, let's just take a look at the render prop example really quickly before we actually look at the hook example really quickly. You'll notice here that in order for me to actually use my render prop, I basically have to define a new component, and then that component is the one that's going to actually go ahead and render my component. So effectively, I'm creating a wrapper around my component. And the same thing was true with the higher order component. In order for me to actually get this sort of extra logic of having this hover state, I had to define a new component that's going to basically wrap my component to then get this sort of extra logic. And so this, of course, in a simple example, we just have like the one wrapper. It's not a big deal, but sometimes you actually have examples where you have wrappers around wrappers around wrappers around wrappers. And so to kind of solve this problem, hooks allow us to sort of actually extrapolate logic into sort of a separate function without actually having to create another wrapper. Let's actually take a look at an example of this right now. Okay, so once again, as you can see, same setup as before. We're just trying to sort of share the hover state across multiple components. So if I hover, it turns red. If I don't hover, it's no longer red, as you can see. But now, instead of using either a higher order component or a render prop, we're actually going to be using a custom hook. Let's actually see what this custom hook looks like and how it actually gets used. So as you can see here, we basically once again have our main app component, and then we have this hook that we're calling useHover. So useHover will basically give us two values. The first one is going to be the actual hover ref, which we're soon going to see how that gets used, and then it actually gives us the value of hovered, whether or not we are in fact hovered or not hovered. Once again, we're going to have the same setup. We're going to have a simple style object, which is going to have the background color dependent on this hovered state. If it's hovered, then red, otherwise it's an empty string. And then we can pretty much go ahead and define our div right over here. Now, one thing that I want to already point out that's kind of crucial here, and this is kind of the whole point of hooks, especially when it comes to using custom hooks for custom logic, is that there's no wrapper here. You'll notice that I'm not having to put any sort of other components around my component. The app component is not getting sent in to anybody. There's no other divs that are surrounding it. I have my own div defined right over here, and then this is a div that's going to have the logic to determine of whether or not it's actually being hovered or not hovered. There are no wrappers. Now, how is that achieved? Well, as you'll notice, one of the things that the useHover hook is actually giving us a ref, right? So it gives you an actual ref. This is a ref that's actually going to get created using the useRef hook, as we'll soon see. We then take this ref and then we attach it to this div, right? And now let's actually see how this gets used inside of the actual useHover hook. If you come to the use hover hook, you'll notice that it pretty much uses state to define a value and then set value. And then here you can see it's actually defining that ref. So this is the very ref that it's actually going to return to us, the consumers of this hook. It then pretty much defines these functions: handle mouse over, handle mouse out. If you're mousing over, it'll set the value to true. If you're mousing out, it'll set the value to false. Then within the useEffect, what it basically does is it actually grabs the node out of the ref.current. So at this point, it already assumes that you have your ref attached to the div that you want to use it, or to whatever element you want to actually hover. And it grabs the node out of it and actually does a check to see that we do in fact have this node. And then it pretty much just attaches event listeners. It says, let me attach the mouse over event listener, and then let me attach the mouse out event listener. And then as these events actually get fired, these functions get called, ultimately setting these values to either true or false. And then finally down here, we're actually going to go ahead and return the ref and then return the value. The ref actually representing the ref that we can attach to our element that's going to get used here inside of this useEffect. And then the value actually representing the value of whether or not we are in fact getting hovered or not actually getting hovered. And so that's pretty much how we can actually use this sort of same reusable logic across multiple different components without having to actually wrap our component with anything else, because there's no higher order component, there's no render prop, but we can actually do this using a custom hook. All right, so the next question on our list is, what is the useEffect hook and how does it actually work? So the way that I would answer this is basically the useEffect hook can pretty much do three things, right? It basically acts like a component did mount. It basically acts like a component did update, and it also can act like a component will unmount. Let's take a look at an example of how it achieves all three. So the first thing we're going to do is let's actually take a look at how it actually behaves like a component did mount as well as the component will unmount. So if you look at this example right over here, all I'm really doing is if I click anywhere in the document, I basically get this alert saying I have been clicked. So effectively what I've done is I've gone ahead and I've attached an event listener on my document. Now typically pre-hooks, the way that you do this inside of a class component is you'd go to your component did mount, and then you'd pretty much say document.add event listener and go ahead and attach your event listener to the document that anytime you're getting clicked, you want you to go ahead and do something. And then what you would do is in your component will unmount, you'd have like a separate lifecycle method called component will unmount. You pretty much go ahead and remove that event listener. So now in order to achieve that inside of a functional component, we can now actually go ahead and use the useEffect hook. So you'll notice here I'm actually defining the useEffect hook. And for the dependency array, I'm pretty much setting this up as an empty array. And this pretty much means that this will only run when the component actually updates the first time and never again, pretty much making it behave like a component did mount. And so pretty much all I'm doing there is I'm just going to go ahead and say document.add event listener, listen out for the click event. When the click event happens, go ahead and call the handle doc_click function, and all that's going to do is just going to alert I have been clicked. So we've pretty much now seen how useEffect can actually work like a did mount. Now let's go and see how it's going to work like a will unmount. And so all you do is inside of your useEffect, you pretty much define what's known as a cleanup function. You give it a function, you return this function, and this is the function where you pretty much do your cleanup. And so in this case, all we're really doing is we're pretty much just doing document.remove event listener. We're just going to go ahead and take the event listener away, so therefore the document will no longer listen to this event listener. So now we've effectively seen how useEffect both works like a did mount as well as the component will unmount. Now let's go ahead and see an example of how this actually works like it did update as well. Hey, if you're enjoying this video so far and you feel like you've actually learned something, you feel like it's useful, definitely drop a like in the video. It really does help out the channel. Also, if you feel like I've missed any questions so far that you feel like I should be asking in an interview, definitely leave a comment down below. I'd like to hear from you about which questions you think I should be asking, or which questions maybe you would ask yourself if you'd be interviewing a candidate. And as with that sort of awkward sales pitch out of the way, let's take a look at how using a useEffect hook as a did mount or as a did update actually works. So what you see on screen right now is I pretty much have the words hello code sandbox start editing to see some magic happen, but then I have this button here that says click me, and every single time I do, the number sort of increments, but in addition to the number incrementing, I also get a new console log that says you have updated the number. Now let's actually see how I did that. If you come into the actual code, you'll notice that I'm using the useState hook to initialize the number state variable with the value of 0. I have a set number function out of state. I have a useEffect hook right over here. Now here's where the sort of magic sauce happens. In the useEffect array, or in the dependency array, instead of it being an empty array as we kind of previously saw when dealing with the sort of event listeners, when we're kind of treating it as a did mount, now I'm actually passing this number argument or this number variable from the useState. I'm now passing this as an argument to this array of the dependency array of useEffect. So basically what useEffect is now going to do is it's pretty much going to look at this number variable and say every single time the value of number changes, I'm going to go ahead and run my effect again. And so that's exactly what's happening here. I have this button down here in the JSX that has a click handler. Every single time I click on that click handler, I'm pretty much going to go ahead and call the setNumber function, incrementing the number by 1. And then when that happens, useEffect will pretty much look at the number argument, see that it has in fact been changed. And when that happens, it'll once again run the console log inside of it because the effect pretty much runs again. And so this is how you can actually use useEffect as a component did update. So we've seen how it works as a did mount, a component will unmount, as well as a component did update. So the next question is, what is React.Memo? And so the answer that I would like to hear is that React.Memo pretty much allows us to make a component only render if its props that it's accepting are in fact changing. Just because my parent component is changing, but if my incoming props have not changed, I don't want to render again. And so previously, instead of a class-based component, we can use the lifecycle method of like should component update, or alternatively, you can actually use like a pure component instead of just a regular component. But how do we do this using a functional component? And the answer is that's exactly where React.Memo kind of comes into play. Let's actually see this in the code. So as you can see here, what I pretty much have is the app component that pretty much renders the child component, right? And now the app component has its own local value here that it's, defining with state. That has a useState hook that pretty much sets the local value. And then every single time you pretty much click on this button, we're going to go ahead and actually change the local value. Now you notice the child component actually has a console log that says I am rendering, because the idea is what I want to kind of indicate is that every single time that the app component goes through a render cycle, the child component will also go through a render cycle. But what's important to notice here is that the child component is going to go through a render cycle despite the fact that it's not actually receiving any props. In other words, it doesn't really have any reason in and of itself to kind of go through another render cycle. The only reason why it's re-rendering is because its parent, in this case app, is rendering again. And the reason why app is rendering again is because its own local state is in fact changing. The child isn't actually receiving any props, therefore technically should be rendering again, right? So if I now come here and I show you this, you can actually see that if every single time I'm actually pressing on the button change local value, we get the console log again that says I am rendering. Now, of course, in this example, it wouldn't really make much of a difference. It's a very small application, so there's really no reason to kind of optimize the performance. But sometimes this can actually cause some, performance slowdowns because you pretty much have what's known as wasted renders. So now we can actually go ahead and use React.Memo to kind of rectify this problem. So here you can see I'm importing Memo from React, and all I'm going to do is I'm pretty much going to take the child component and wrap it inside of Memo. So all I'm going to do is just call the function like so. And now you'll notice that every single time I'm actually going to go ahead and change the local value, the actual local component app is actually going through another render cycle, but the child component is not actually rendering, which is indicated by the fact that we're no longer getting the console log of I am rendering. Okay, so this next question actually kind of builds off of the previous question, and that is, what is the use callback hook? How does it work? What's it good for? And by the way, if you want to kind of see more about like React.Memo, use callback, and soon we're going to be talking about use Memo as well. If you want to kind of see more about this, I actually have a video dedicated just to those three sort of APIs in React. I'll leave a link to the video down in the description box below. But in any event, what is use callback, right? So let's actually go back to our code now and kind of see what does use callback actually do for us. If you come back to this code over here, you'll notice that it actually looks very similar to the code we just had when looking at the sort of Memo example. And so pretty much this child component is now wrapped in Memo. But one thing that's kind of happening different now is the child component is in fact receiving a prop passed down to it. But the caveat here is that the prop that is actually getting passed down to the child component is in fact a function. So I'm pretty much defining a function over here. I'm just calling it somefunc. It's not actually doing anything, but this is in fact the prop that we're pretty much passing down to the child component. Now if I open up my console here, you'll notice that every single time I'm actually changing the local value, despite the fact that now my child component is wrapped in a Memo, and presumably the prop that is getting passed to it is not actually changing because it's just a function, right? Still it's actually rendering again and again and again. And so the answer is that that's actually not true. What's really happening is the argument that's getting passed to it, or the prop that's getting passed to it, is in fact changing, right? Because what's happening here is every single time the app component re-renders, a new function gets created that's actually getting passed down to the child component. So even though the function is equivalent, it's actually doing the same thing, but it is becoming a brand new function in memory. In other words, the function kind of gets recreated again and again and again on every single render. So therefore, even though now we're using Memo, but since a new function is getting passed in every single time, the Memo sort of thinks, oh, I have a new prop coming in, let me go ahead and re-render. So to solve this problem now, this is where use callback kind of comes in. So you'll see here I've actually imported use callback from React, and then all I'm really doing is I'm pretty much creating a new variable called memoizefunc, which pretty much is going to be returned to me from the use callback hook. So I use the use callback, take the function I want to kind of memoize, pass it into the use callback, and then the second argument would basically be the sort of dependency array. In other words, when do I want this function to kind of get recreated? only if anything in my dependency array changes. A lot like the useEffect dependency array works. In this case, I never really have any reason for the actual function to change. Therefore, I can just go ahead and use an empty array to kind of signal that I never want this function to kind of get recreated. And so now what happens is, instead of me having a function that's going to get recreated every single time when the app component runs, I now actually have a memo-wise function that will always be pointing back to the same function that was allocated in memory. So now down here in the child component, instead of actually passing it the sum func, I'm actually going to go ahead and pass it the memo-wise func. Now, if I come back to my actual application here, you'll notice that every single time I hit the button to change the local value does in fact change, but the child is now no longer rendering because the function is now a memo-wise function and is not every single time becoming a new function, therefore bypassing the memoization of the child component. Alright, so the last question is, what is useMemo? So previously with useCallback, we actually saw the ability to kind of memoize a function. What useMemo allows us to do is to actually memoize values. Let's take a look at an example of this in the code. So as you can see here, what I pretty much have is I have an array that goes from the numbers 1 through 9, right? And then what I have is inside of my JSX, I pretty much have an H1 that pretty much has, it says largest number, and then it goes ahead and runs the function called largest number to kind of compute that and get me the largest number out of the array. Now, for the sake of this example, let's just assume that the array is not actually a small array that just goes from the numbers 1 through 9. Let's imagine that it's actually somewhat of a really large array that's not sorted, and actually finding the largest number is going to be somewhat of an expensive operation. And so the problem now that we're faced with is that every single time I click on this change local value button right over here, the app component goes through another render cycle, thereby forcing the large number function to run again and again and again and again, which is kind of silly. Now again, we can solve this in many other ways. This is of course a very contrived example, but the point that I'm trying to highlight here is that we have a serious inefficiency within our code here, because basically what's happening is we have a function that's doing expensive work and it's doing it again and again and again, even though the outcome is always going to be the same because the input is the same, right? And so that's exactly what useMemo allows us to do. useMemo will basically give us the memoized value of this particular function. So in other words, if the last time that this function ran, it gave us the number 9, every single time now that this function will run it again and again and again, it's just automatically going to give us the number 9 without actually recomputing the function again. So once again, you'll see here, if I actually come and I click on this button right over here, you'll see that I get the log I am working. I am working as the console log that's actually defined inside of the largest number function. And so what that kind of indicates to us is that every single time the component re-renders, the largest number function runs again and again and again. But if instead of me actually using largest number function right over here, I'm actually going to use the value that I get out of memoized value, now let's see the difference that we're going to get. Okay, so now we're actually using memoized value. Let's come back and click on this button, and as you can see, local value is in fact changing. The app component is actually going through its own render cycle, but the computation for getting the largest number is not happening again and again. We just use a sort of previously computed value of the number 9 because it's been memoized using the useMemo hook. Well, anyways, that does it for this video. I hope you enjoyed it. I hope you found it useful. If you did, please drop a like. Definitely subscribe. I upload weekly videos, and I'll see you in the next one.